everyone, here is the video going over graphing linear inequalities. So after you are done watching this video, you should be able to graph a linear equality in different forms, determine if you draw a dotted or a solid line, determine where to shade on the graph, and to determine the solutions for that linear inequality. So before we start graphing anything, we do need to pay attention to some key vocabulary. So we have these inequality symbols that we have talked about before: greater than, less than, greater than or equal to, less than or equal to, and we have solutions for your inequality, and a solution is any point that makes the inequality true. Now, since we are graphing linear inequalities on a coordinate plane, there's a couple key things that we need to pay attention to if we're going to have a solid line or a dashed line. A solid line is when you have y is greater than or equal to, or less than or equal to. And a dashed line is when y is just greater than or less than. So we're going to have a solid line essentially when you have the line underneath the inequality. So that's kind of like a little trick. If I have a line underneath my inequality, it's going to be a solid line. Now we also need to determine where we're going to shade, and this will make more sense once we actually do an example. But you are going to shade above the line when y is greater than or equal to. We're going to shade below the line if y is less than or equal to. And we don't shade anything when y is just equal to, because that's just graphing a normal line. So as I said, this will make a little bit more sense once we do an actual example. I will reiterate the solid versus dashed, above and below, as we go through the next three examples. So here's our first example. It is in slope-intercept form. So when I say translate, we just need to talk about what this means. So this is saying that y is greater than or equal to negative 3x minus 2. So the first thing I want to do is I want to actually graph this line like we normally graph lines. So I'm going to say that my slope is negative 3. And my y-intercept is 0, negative 2. So I'm going to graph it like I normally do. I'm going to start at 0, negative 2. I'm going to plot a point. My slope is negative 3, so from this point I'm going to go down 3 over 1, down 3 over 1. And I can go in the opposite direction as well. And I'm going to plot as many points as I can to create a line. So now I can connect those. Now before I connect those, I do need to determine if it's going to be solid or dashed. If I look at my inequality, I have the line underneath the inequality, so that tells me that my line is a solid line. So I'm drawing a solid line through those points. So solid line. Now I need to determine if I'm going to shade above or below. If I look back at my inequality, that tells me that it is greater than, so greater than is going to be above the line. So when I say above the line, I would start on my line, essentially, and shade everything up above it. So that's going to be this entire area over here. So this whole section, I'm going to shade in. And the reason why we shade is because with inequalities, you have multiple solutions. Essentially, you have an infinite amount of solutions. Your solutions can be any point that is in the shaded area, or if you have a solid line, it can be any point that's on the solid line. So identify solutions. A possible solution to this inequality could be, and I can just pick any point that's in my shaded area. So that point is at 7, 2, because it is in the shaded area. And again, you can pick any point that's in the shaded area or any point on the solid line. All right, this one is in point slope form. So it is saying that y plus 7 is less than 1/2 times x plus 4. So for point slope form, I'm going to start by identifying my slope, which is 1/2. For my point, again, I'm taking out the opposites. So this becomes -4, -7. And I can go ahead and start plotting my points. So -4, -7 is right here. My slope is 1/2, so I'm going to go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. And as I connect these points, if I look back at my inequality, it's just a less than. So that means I am going to have a dashed line because it does not have the or equal to. So as I connect these points, I'm going to go ahead and make it a dotted line since it does not have the or equal to. And if I look back at my inequality, it is a less than. Less than means I'm going to shade below. So I'm going to start with my line, and I want to shade everything that is underneath that. So going straight down. So I'm going to go ahead and shade this area of my graph. And all of my solutions can be in that shaded area. Now with this next one, identifying solutions, I'm giving you a list of points. So we want to actually plot these points and see where they are. So 5, -6 is right here. That's in the shaded area. So yes, that is a solution. 0, -5 is this point right here. Now this point is actually on my line. But because my line is a dashed line and not a solid line, that means all of the points on that line are not solutions. So this one is a no. 10, 10 is over here in this first quadrant, not in the shaded area, so that's also a no. And -9, 7, let's see, -9, 1, 2, 3, 4, 5, 6, 7 is over here. Again, not in the shaded area, so that is also not a solution. So far we've graphed inequalities that are in slope-intercept form. We also have point-slope form, and we also have standard form. So standard form is next. So standard form is when we have our x's and y's on the same side. So our first step is to solve for y. So I'm actually going to rewrite it. 3x minus 6y is less than or equal to 6. To solve for y, we start by moving our x. So minus 3x from both sides. This gives me -6y is less than or equal to -3x plus 6. And then I'm going to divide both sides by -6. Now, one thing that you have to remember with inequalities is since I am dividing by a negative number, that actually flips my sign around. So instead of less than or equal to, I now have greater than or equal to. And then I can continue to simplify. So -3 over -6 is a positive 1/2. Since they're both divisible by 3, 6 divided by -6 is -1. So this right here is the inequality that I am actually going to graph. So it's telling me that my y values have to be greater than or equal to 1/2 x minus 1. So I'm going to graph the line. So it's in slope-intercept form now. So m is 1/2. My y-intercept is 0, -1. So I'm going to start by plotting that point, 0, -1. Slope is 1/2, so I'm going to go up 1 over 2, up 1 over 2. I'm going to plot as many points as I need to try to make my line as accurate as possible. And then I need to determine if I'm going to have a solid or a dashed line. If I look back at my inequality has the or equal to, so that means it is going to be a solid line. So as I connect these points, I'm going to go ahead and make it a solid line. Again, that was because it had the or equal to. I also need to figure out where I'm going to shade. My inequality was a greater than or equal to, so greater than means I'm going to shade above the line. So on my line, I want to go straight up, and that is where my shaded area is going to be. So I'm going to shade this entire section up here. And then to pick my solutions, I can pick any points that are in the shaded area. So I'm going to go with this point over here and this point over here. So my first ordered pair that I picked was 2, 5. The second point that I picked was -3, 0. You could also pick any point that's on the line since this was a solid line. 2 points that are not solutions, just anything that's not in the shaded area. So this one and this one. You have lots of options. So the first point that I chose was 4, -5. And my other point that I chose was 0, -5. And that concludes our little lesson on graphing inequalities. I hope that helps you understand how to graph the different forms of linear inequalities.